Hello everyone. So in this lecture, I will walk you through all the essential kubectl service SVC commands. So first, I will set up the alias k equal to kubectl. Next, list all services in the default or the current namespace. So for this command is kubectl k get svc, and this displays a list of all services in your default or the current namespace, showing their name, type, cluster IP, external IP if any, ports and their age. Next, list all services across all namespaces. So for this, you can use k get svc followed by dash capital A, and this lists services from all namespaces in the cluster, and this is useful for cluster-wide service discovery and troubleshooting. Next command is list all services for a specific namespace, and for this k get svc followed by dash n and the namespace name, and this will list services from a specific namespace in the cluster, and this is useful for listing and troubleshooting services for a specific namespace. Next command lists services with more details, and for this k get svc dash o and space wide, and this shows additional details about services including selectors and endpoints. Next command describe a specific service. So k describe svc followed by the service name, and for this provides detailed information about a service including its endpoints, selectors, ports and events. Next command describe a specific service for a namespace, and for this k describe svc followed by the service name, nginx service, and then dash n and the namespace name, and this provides detailed information about a service including its endpoints, selectors, ports and events within a namespace. So this will give very high detailed information, but k get service will give limited information. And for next all the commands, just make sure you have dash n if you are working within a specific namespace, or if you omit dash n, it will revert to the default namespace. So just make sure you remember this part. So for the next set of commands, I may or may not show this, but you just have to keep this in mind. So get service details in YAML format, and for this k get svc followed by the service name, nginx service dash o for output and YAML, and this outputs the complete YAML configuration of the service and useful for understanding the service full specification. Next command get service details in YAML format. So get svc nginx service o YAML, but this is for specific namespace, and same thing outputs the complete YAML configuration onto the console. Next, export a service to a YAML file. For this same command, but we will just redirect the output to by following this greater than operator and file name, and this exports a service configuration to a file, which is useful for during the exam when you need to modify complex services or use one services as a template for another. Also, in case you want to take a backup, so let's say the exam has asked you to modify some existing service and you don't want to mess up, make sure you back up first, and then you can do k edit service to modify the service in question. Next command get service details in JSON format, and same command k get svc but dash o for output JSON, and this is optional, so dash n or you can omit for default namespace. This will show the output in JSON format. So returns the service details in JSON format, which can be passed programmatically or for advanced analysis. Show service labels, and the command is k get svc dash dash show labels. Displays all services with their associated labels, which is useful for understanding service selection. Filter service by labels. So you have k get svc dash l and the label, key and the value, and this is optional. This will list only services with the label app equal to nginx, helping filter services in crowded or in environments or production environment where there are lots of services and lot of namespaces. So basically service will redirect to your pods based on the selector. So if the pod has the same selector, the label, key and value, then the traffic would be directed to those pods. Next command, sort services by creation timestamp. And for this, k get svc dash dash sort by, then dot metadata dot creation timestamp. And this will list services sorted by creation time, showing oldest or newest services based on sort order. Next command, list services with custom columns. So k get svc dash o output custom column names. So this will be the column name and then the column value dot metadata dot name. So this we are making a table. So first column name and metadata dot name, then second column name type. So this is whatever you provide. It's user provided name, but this is what is inside the YAML or the configuration dot spec dot type. Then third column name cluster IP colon, then dot spec dot cluster IP, and last column name external IP dot status dot load balancer dot ingress first object. So 0 is the first object dot IP. Displays service information in custom columns for better readability and focus on specific attributes. Next command, check service target port mappings. K get svc name of the service, o JSON path, then we construct the JSON path. So it is under dot spec dot ports, all ports. So this is asterisk means all ports dot port followed by colon and again JSON path dot spec dot ports and the target port. So this will show all the port mappings. There can be multiple. So shows the port to target port mappings for a service, and this is helpful for confirming traffic routing configuration. Next command, watch service changes in real time. So k get svc dash dash watch, and this will continuously monitor and display service changes as they happen, and this is useful for debugging service updates. Next command, check the cluster IP of a service. So k get svc service name dash JSON path, then we will construct a JSON path dot spec and we will go to the field cluster IP. This extracts and displays only the cluster IP address of the service. Useful for scripts or when focusing on networking issues. Next command, create a basic cluster IP service. So k create service cluster IP. This is a keyword followed by whatever user friendly name, Nginx service, and listening on port 80 and backend port is 80. So creates a cluster IP service named Nginx service that forwards traffic from port 80 to target port 80 on pods with the matching labels. Next command, create a node port service. K create svc type of service node port. So this is fixed string, name of the service web app, TCP frontend 80, backend 8080, node port 30080. So this creates a node port service named web app that maps service port 80 to container port 8080, exposes the service on port 30080 on all cluster nodes, automatically sets pods with web app label. Node port services makes your application accessible from outside the cluster through a dedicated port on every node. Next command, create a load balancer service. K create svc fixed string load balancer, name of the service frontend, TCP frontend port 80, backend port 80. And this creates a load balancer service that provisions an external load balancer in supported cloud environments. Create a service for existing deployment, and the command is k expose deploy. This is a keyword, deployment name Nginx on port 80, target port 8080 dash dash name and Nginx HTTP. This is your service name. This is the deployment name, and we are saying expose on port 80 frontend and backend port 8080. And the command, this will create a service for an existing deployment, exposing port 80 and targeting port 8080 on the pods. Next command, deleting a service. So k delete svc followed by the service name. So this is straightforward. Next command, create a service with specific selectors. So k create service cluster IP, type of the service, name of the service, TCP 80 frontend, backend 8080, dry run, client, OYAML. So this will not create, just it will do a dry run. We are first redirecting to a file. Then we are saying set selector local. So because we are targeting local file, -f for the file name, frontend svc.yaml, and we are setting this selectors. So app frontend tier web OYAML, and this will update this service. It will take this service and it will create a new file with the selectors. Then we just apply this second file. So all the pod which have this particular label, they will be part of this service after this command. So it creates a cluster IP service with specific pod selectors to target only pods which has labels app equal to frontend and tier equal to web. The command chain uses dry run to generate YAML, add selectors, and then applies the configuration. So create service with multiple ports. So K creates SVC, type of service, so this fixed keyword, name of the service, we are calling it multi-port SVC, and we have 2 ports, 80 frontend, 8080 backend, 443 frontend, 8443 backend. Creates a service that forwards traffic on multiple ports, HTTP and HTTPS in this example. Next command, create a headless service, no cluster IP. So K create SVC, cluster IP, headless SVC, -- cluster IP. So this is the only thing, important part, we are saying none. TCP 80, backend 80. This creates a headless service that does not have a cluster IP but provides DNS entries for each pod. Useful for stateful applications. Headless services allow direct connections to specific pods rather than load balancing across them, which is essential for applications like databases where clients need to connect to specific instances. Create an external name service. K create SVC, external name, this is a fixed keyword, name of the service, external name, and this is the our DNS name, api.externalservice.com. This creates an external name service that maps to an external DNS name, and that allows application to use Kubernetes service discovery for external services. So pods can go to this name based on the service. So pods can connect to this service on this name, external SVC, and this have knowledge of this API which has external endpoint. Set service session affinity. So K expose deploy, name of the deployment, port 80, name sticky SVC. So this is the name of the service. We are setting a session affinity for client IP, and what it does is creates a service with session affinity to client IP, ensuring requests from same client IP go to the same pod. This creates a service that routes requests from the same client IP to the same pod, and this is useful for maintaining session state in web applications, improving cache efficiency, ensuring consistent backend connections. Unlike the default none affinity, which is random load balancing, client IP affinity provides better user experience for stateful applications, though it has limitation with shared NAT and a default 3-hour timeout. Next, create service with custom selector. So K create SVC, cluster IP, type of service, name of the service, TCP frontend 80, backend 8080, selector, and we have provide the label app key, and frontend one more label, key is tier and web is the value. Creates a service that targets pods with specific multiple labels, and that allows precise backend selection. Create a service targeting a stateful set. So K expose STS, and this is the stateful set MySQL, and MySQL listens on 3306 and the service name. So creates a service that exposes a stateful set, particularly important for stateful applications where each pod may need a stable identity. Create service targeting daemon set pods. So K expose DS, and this is the daemon set name. This is listening on port 9100 and the name of the service which we are creating or which we are exposing, because this is daemon set. So this will immediately create a service pointing to this daemon set. Creates a service that targets pods created by daemon set. Useful for exposing monitoring agents or other per node services. Creates service with external IPs. K expose deploy, name of the deployment, type cluster IP, frontend port, and the external IP. This creates a service with specified external IP, making the service available on a specific external address. This is useful when you need to expose a service on a specific IP address that is routable outside the cluster. For example, when you have a specific IP address allocated for your service, when integrating with external DNS systems that require fixed IPs, when you need to expose a service on a predictable address for external clients. Next, update service ports. So K patch SVC Nginx service -p. Then what we are updating, spec ports, port 8080, target port 80 and name HTTP. And this will modify an existing service ports without having to delete and recreate it. So you can do same with k edit svc command also, but this I'm just pointing out which parts we have to edit. So we go to the spec and inside ports, and we go to the port, target port and the name section. Next command, update service session affinity. So k patch svc. So similar thing. So where we have to go? So session affinity client IP, and this modifies the service to use client IP session affinity, ensuring that requests from the same client IP go to the same pod. And this is useful for applications that require session stickiness. Next command, set specific node port for a node port service. K patch svc, name of the service, and where we have to go. We have to go to spec ports, port, node port section. Assigns a specific node port, in this case 30,080, to the service. Useful when you need a consistent port across nodes for external access. Create a service with target port name instead of a number. So K create SVC, name of type of service cluster IP, the name which we are providing, TCP80, and the backend protocol, the port name, no, not the protocol, the port name, and not the number. So creates a service referring to a named port, HTTP, instead of a port number. This offers flexibility when port numbers might change, but names remain consistent. So in the deployment or the pod, this will be a named port. So we are referring to this. This can be 80 or 8080 or anything, but we are referring to a named port instead of a named number. Create service with specific namespace. So K create SVC cluster IP and the service name what you want to call, and we are specifying the namespace. In this case, this namespace must exist, security NS and same frontend port, backend port. Create a service in specific namespace, essential for multi-tenant clusters or when implementing security boundaries between applications. Get service endpoints. So K get EP followed by the service name. Shows the endpoints. That endpoints are the pod IPs and the ports. So it will list more than, so let's say there are 3 pod, it will list 3 endpoints for 3 pod and the ports that the service is connected to based on its selectors. And you can, this is in the default namespace. So I'll just repeat once again. So if you can add -n and add specific namespace if you are working for a specific namespace. Next, check service logs. So K logs -l app equal to Nginx. Retrieve logs from pods that match the service selector. So the service have this selectors app equal to Nginx, and because of that we are just targeting the pods which are serving that particular service. Helpful for troubleshooting service issues. Check DNS resolution for a service, and command is krun. This is the pod name, and we are using this image busybox. It's very common image. --rm, like remove after you run the command. I interactive tty restart never, and then -- and then what command we want to run. So this is like a temporary like a ephemeral pod, it will just run this command ns lookup and followed by the service name. So if this is successful, it will just print one line and it will immediately shut down. Creates a temporary pod to test DNS resolution for a service, which helps troubleshoot service discovery issues. Check service connection from a pod. So krun, again we are spinning up a temporary pod test curl, and this is user friendly name and image. We are using curl images slash curl, remove it, interactive tty, restart never, dash dash, and then we are just running one single command, curl and name of the service. So if it is a like HTTP, you can use this command. Creates a temporary pod to test connectivity to a service, verifying that the service is accessible and functioning. Test service load balancing. Krun it -r remove DNS test. Then we are spinning up a busy box image and we are just doing a ns lookup. But in this case, we are calling a service which is in the other namespace. So this is the format: service name followed by dot namespace name dot svc. So this is fixed dot cluster dot and dot local. Test DNS resolution for a service in another namespace using the fully qualified domain name. And this is important for cross namespace service communication. Next command, test service access from different namespaces. So krun pod name test access, the image name, remove it, restart never, -n in this namespace, and then because this pod we are running in this namespace, and then we are doing a curl and silent nginx service, and this is going to the default namespace. So this pod is being launched in namespace 1, which is other namespace, and this is going to second namespace default, and that's why we have to give fully qualified service name .svc .cluster .local. Test if a service is accessible from a different namespace, which is important for cross namespace communication. So here it could be default or it could be any other namespace. So namespace 1 to namespace 2. Check TCP connection to a service. Krun netcat test image busybox, remove it, restart never, -- and one command only, netcat. This is just check the communication, nginx service and AT. So this will run and it will, this is basically like a telnet command but a shorter version. So it will just see verbose and whether the connection is successful or not. So it will just print out succeeded or open or cannot unreachable. Test TCP connectivity to a service on a specific port and useful for verifying network policies and service availability. Debug service connectivity with temporary pod. So kdebug it image Nicoloca netshoot, name of the pod target nginx pod. Creates a debugging container with network troubleshooting tools attached to an existing pod's networking namespace. So this will debug this particular nginx pod. So if it is a part of a service, you can troubleshoot this particular pod. Check service access from a temporary debug pod. So krun again it remove debug, name of the pod, and we are using this image and we are running a one-time command. This will die immediately after issuing this command, curl -v verbose and the service name -at. So they both are in the same namespace. Creates a temporary debugging pod with network troubleshooting tools to test connectivity to a service, essential for verifying access controls and network policies. Next command, test service DNS records using core DNS. Krun DNS test image name info blocks DNS tools, remove it, restart never, -- and then we are launching a shell detached mode and we are just running a advanced command, dig command. This is being used in Linux and Mac SRV and the name of the whole service name. This uses a specialized DNS tool to examine the service DNS records in detail, providing insights into how Kubernetes service discovery works. Check who can edit a specific service. Kauth can I update svc fixed flag -- name of your service. Checks if the current user has permissions to modify a specific namespace important for maintaining security in a shared cluster. Check service account permissions for accessing a service. K-auth, can I get services as who, system, service account. This is fixed flag service account, default namespace, and this is actual name of the service account. So the format is like this. So we are checking not as yourself but as someone else whether they have access or not. Verifies if a specific service account, this name, can access services. This is important for RBAC testing in CKS or probably in CKA. Create an ingress for a service. K create ing, name of the ingress, web ingress, and we are creating a rule app.example.com/star. So any web request that has this in the front, like in the URL, you can say, right? What you type in your address bar of your browser, and this is pointing to the backend. This is the name of the service, Nginx service, which is listening on port 80. Creates an ingress resource that routes external HTTP traffic to the service based on hostname and path. Connect service to external load balancer via annotations. K annotate service name, name of the service, services.beta.kubernetes.io, AWS load balancer, type NLB. So this is how you annotate a existing service. Once you annotate, it will become part of the load balancer. It means the load balancer will be able to redirect traffic to this particular service. Adds cloud provider specific annotations to a service to customize the external load balancer behavior. Monitor service endpoint changes. K get EP endpoints, name of the service, -- watch. Continuously monitors changes to service endpoints, which is useful for tracking pod scaling events and health status changes. Use target port mapping for port translation. K expose, deploy keyword, name of the deployment, Nginx, name, port map, SVC, and we are mapping port 8888 to target port 80. Creates a service that maps port 8888 externally to port 80 on the container, which allows for flexible port mapping. And that's all. Thanks for watching.